Hello, my dear students. Welcome back to my class. In the series of learning data structures through C, in the previous video, we discussed about the operations on queues and the values of front and rear pointer. Well, in today's video, we will discuss about the memory representation of queues, and we will also learn how this front pointer and rear pointer is used to insert and delete the elements. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Memory representation of queues, like how this queue is represented inside the computer's memory. So I can represent the queues with two methods. One is the static representation, which is done using arrays. The other one is dynamic representation, which is done using linked list. Let us learn these two methods one by one. Let us understand the first method, that is representing the queues using arrays. The representation of queues, memory representation of queues using arrays. When I say array, we make use of the one-dimensional array here. So the array size is fixed. So it is fixed size. So let us assume you have an 1D array representation here and the size is 5. That is, the queue size is 5. Maximum 5 elements I can store into the queue. And here, to do this insertion and deletion, we make use of two pointers. One is front, the other one is rear. Front and rear will be initially -1. Right. So when we do the insertion, as I said, we need to remember the values of front and rear. I need to do the insertion from the rear end. So from the rear end, the insertion takes place. So when I do the insertion from the rear end, the rear pointer has to be increased. The rear pointer has to be increased. So I just say r equal to r plus 1. So initially front and rear, the front pointer and the rear pointer will be -1. When I say rear equal to rear plus 1, it is -1 plus 1, which is 0. So now what happens? The rear will be pointing to 0. The rear will be pointing to 0. So this is what rear. From the rear end, we enter into the queue and we start at the first, and we just stand in the first position. See, when you enter into the queue, we enter from the rear end, right? And do we stand there itself? No. We enter into the queue and we stand in the first position. Here also, say just assume I am inserting the element 10. That is, I am performing which operation? NQ operation. Right? NQ means inserting. I am inserting the first element from the rear end and it is placed here in the position 0. Then once again I say rear end is 0. Once again do the insertion. Next element I am entering. So I say 0 plus 1. It becomes 1. So it is 1. Now the pointer is pointing to 1. So my next element will be say 20. So rear pointer increased. Once again I say 1 plus 1, it is 2. So here next element will come here and the rear pointer gets increased. Now it is pointing to 2. Again I say 2 plus 1, it is 3. Now the rear pointer is pointing to 3. My next element say 40. Again I say 3 plus 1, so it is 4. So now the rear pointer is pointing to 4. The queue size is 5. Okay, the rear pointer is 4. I am inserting 50. Right? Then once again I say 4 plus 1, the rear becomes how much? 5. When the pointer moves to the next position here, then what happens? I cannot do the insertion because the rear pointer has already reached queue size -1. So when the rear pointer equals to q size minus 1, q size is 5, 5 minus 1 means 4. Rear pointer is pointing to 4. So when the rear pointer equals to q size minus 1, then I cannot do the next insertion. So it has already filled with the item. Then once again when I just proceed with the next, the rear pointer moves forward. It becomes greater, right? And when it reaches the q size minus 1, then it is done. It will tell the queue is full. The queue is full. So we need to learn the algorithm also. In the next coming video, we will see the algorithm of NQ as well as DQ. We will just understand how it is represented inside the memory. Next, what we'll do, we can start deleting the elements. So we say we can perform DQ operation. DQ operation means deleting. So the rear pointer is pointing to 4, right? Now front is minus 1. Then I say front equal to front plus 1. I say front equal to front plus 1. So it is minus 1 plus 1 equal to 0. Now front is here, rear is here, right? Now what happens? I need to DQ this means according to the Q ordering principle, it says FIFO. First in, first out. The first element inserted will be the first to come out. So this has to come out. So 10 will be removed. Then once again I say 0 plus 1. So it is 1. Now see, for NQ I incremented the rear pointer. For DQ I am incrementing the front pointer. For both the operation, incrementation only, but different pointers. For NQ, that is for inserting, we increase the rear pointer. For DQ, that is for deleting, we increase the front pointer. So 0 plus 1, now it is pointing to 1. So also remove this 20. Then again 1 plus 1, it is 2. Now the pointer F is pointing to 2. Again remove this. Then say again increase 2 plus 1, say 3. Now pointer F is pointing to 3. Remove this. Then again say 3 plus 1, it is 4. Now the pointer F is pointing to 4. So again remove that. Right? Again increase 4 plus 1, it becomes 5. So pointer will be moved here. So when the front pointer is greater than the rear pointer, so what happens? Rear is pointing here. Rear is pointing here. When the front pointer is greater than the rear pointer, means the queue is empty. So it has reached out of the bound. It has reached out of the bound. There is nothing to clear in the queue. So queue is empty. Then what we will do? We will once again reset this front and rear. The front and rear will be reset to minus 1. So this is how we represent the queues inside the memory with arrays. That is static representation. Static means fixed. The queue size will be fixed. But here there will be some issues. What happens? I have removed these 3 items, say 40, 50. I have space here in the memory, right? But the rear pointer equals to q size minus 1. Can I do the insertion here in this case? No. In the static representation, when the rear pointer is pointing to q size minus 1, it tells that the queue is full. Even though I have space here, I cannot fill the items. But this I can achieve with linked list because there we have node structure. So in static representation, we have this drawback. We cannot utilize the memory effectively. If I want to use the memory effectively, I can go with the dynamic representation, that is using linked list. So we will only see the representation, but in detail how this linked list is dealt with queues, stacks, all those things we will see in the next coming videos. Now we will see the second type of representation, that is dynamic representation, that is using linked list. So here we go with the dynamic representation using linked list. So as we all know, in the linked list we have something called as node structure. A node is the user defined structure which has 2 parts. One is data part, the other one is the link part. Data part contains the data, say something like 20, and the link part contains the address, which is the address of the next node. So this structure we have to create. And how to create this structure, how to deal with this link, we will discuss that when we will discuss about the linked list in detail. So now you just know you have some node structure where it has data part and link part. In the data part we have data, and the link part we have the address of the next node. So here the address of the first node will be held in front pointer. As we all know, front pointer is one. This is the pointer which is having the link of the first node. Then here we have the data and the link. In the link we will have the address of the next node. So 200. So it is pointing to this node. Again the data for the next node is 25, and the link part we have the address of the next node. So it is 300. Then we have data 47, and the link we have the address of the next node. So 400. Then here we have data 38, and link we have null, and the address of this last node will be held in the rate pointer. So we have two pointers, one is front pointer and rate pointer. Front pointer takes care of the first node and rate pointer takes care of the last node. So two different pointers to take care of the first node and the last node. So in this flow, I can establish the link, I can insert the node anywhere in between, at the beginning or at the ending, with the help of two pointers, front pointer and rate pointer. So how we are going to deal with those pointers? We have to deal with those pointers only when we understand linked list. So this is the structure that what you should know with respect to queues. Front pointer and rate pointer. Well, that's all for today's video. So in the next video, till then, take care. Bye-bye.